This is going to be a little bit more complicated example for us. Still finding and classifying. Classify critical points. But this time our function is going to it's going to be given by 8x cubed minus 24xy plus y cubed. And unlike our previous example where we only got 1 point, this is going to give us more than 1 point. So we actually have to do that plugging in values to the discriminant thing. So let's go ahead. I'm going to go a bit more quickly this time since we've practiced the main ideas before. So I want to find my critical points from 0 equal to grad f. First component of grad f is 24x squared minus 24y. And the second component is 0 minus 24x plus 3y squared. Again, if the partial derivative computing gradient thing is still difficult for you, take a pause here. Make sure you understand how I got that from the partial derivatives with respect to x and then with respect to y. This is going to give me the equations 0 equal to 24x squared minus 24y and 0 equal to minus 24x plus 3y squared. And I'm going to start with this equation and then go on to this one. And I'm kind of trying to model the way that will help you show all your work to get as much partial credit as possible when I work through these. I'm labeling, this is the equation I'm going to think about, so that when I start working with that equation, you kind of know what I'm trying to do here. Let's see, that's 0 equal x squared minus y. So that's just y is equal to x squared. And then I say, okay, I'm going back to my other equation. This is what it was. Minus 24x plus 3y squared equal to 0. And then I'm going to plug in what I found before, y equal x squared. Cool. Very cool. Plus 3x squared squared. So I replaced y with x squared. This is odd. It's going to give me a cubic in the end, and I don't know that I can solve that. Okay, so I'm trying to solve 0 is equal to minus 24x plus 3x to the fourth. And there's two different ways that I could deal with this. I could factor it out, say that's x times minus 24 plus 3x squared. Now I know that this has to be equal to 0, and so does this. A lot of you are just going to divide out that x and say, oh, okay, well, that x doesn't matter. It's in everything. But when you do that, you're throwing away one solution, x equal to 0. So please be careful. This tells me that x equal to 0 will make this whole equation 0. And this tells me 0 equal to minus 24 plus 3x squared will make this equation equal to 0. And that one gives me 24 equals 3x. Oops, sorry, that's not squared, that's cubed. Cubed, 8 equals x cubed. That is the one cubic thing I know. That means that x is equal to 2. So I got two different solutions for x from this. Either x is 2 or x is 0. So from y equal x squared, I can get the point 0, 0. Or from x equals, actually, let's do this all at once. From x equals 2, I'll get y is equal to 2 squared is 4. So my points are going to be 0, 0, and 2, 4. So I'll just put a box around that because it's going to matter to me later. So I found my critical points. And next up, I have to classify them. So I'm going to go ahead and write the points I care about. And I'm going to write my gradient. 24x squared minus 24y. And minus 24x plus 3y squared. You don't have to rewrite this. It's just because I know I'm going to need those first derivatives. To get d equal to f sub xx, f sub yy minus f sub xy squared. So f sub xx is going to take a derivative with respect to x of the first component. So I got 48x. F sub yy, derivative with respect to y of the second component. That's 6y. And f sub xy is f sub x, that component, and then a derivative with respect to y. So that's just going to give me minus 24. So this is going to be 48x6y minus 24 squared, which is, okay. So 8 times 6 times 6 xy, that's 48 is 8 times 6, minus 4 times 6 times 4 times 6. The two negatives cancel out. So let's see. So 6 squared can come out front. So can the 8. And then all that's left over is a 2 down in that last component. 4 times 4 is the same as 8 times 2. So I pulled out a common 8. And that's my discriminant. That's about as simplified as I can get it. I don't know what that number is, but I don't care. And next up, what I need to do is I need to use this to classify my point 0, 0, and 2, 4. But now we see that there's an x and a y in here, so I'm not just going to get any number d. I need to actually calculate the specific number d for each point. So at 0, 0, I'm going to get d is equal to 6 squared times 8 times 0 minus 2. And so I don't know what this is going to be, but I know it's a negative number from that right there. And if I go back to my list of ways to classify things, when I have d less than 0, I don't have that extra step. I just know right away this is a saddle point. So I can go ahead and say that this is a saddle point. And then at 2, 4, I'm going to get d is equal to 6 squared times 8 times 2 times 4 minus 2. So that's 6 squared times 8 minus 2 is 6. Again, I don't know what this is, but I do know it's a positive number. And remember, when the discriminant is positive, I have to check the second derivative. So f sub xx was 48x. So that's going to be 48 times 2, which is a positive number. So since I have the discriminant is positive and the second derivative is positive, if I went back to my table, that would tell me that this is a relative minimum. And so at this point, the problem's done. We found the critical points, and then we classified them.